Have you ever just sat there and wondered, what is actually going on inside the mind of an AI when it predicts the next word? It feels like pure magic. Well, today we're going to pull back that curtain and show you the surprisingly simple machine that's really running the show. So how does it do it? How does it seem to just know what to say? Well, I'll tell you right now, it's not magic. It's a trick, a really clever one, and we're about to show you exactly how it's done. Okay, let's start with a super simple example. If I give an AI this phrase, the cat sat on the, I think we all have a pretty good idea of what's probably coming next, right? Of course, Matt. But here's the crazy part. For you and me, that's just intuition. It's a no-brainer. For an AI, it is not obvious at all. It's a calculation. It's a very precise process that's based on all the data it's ever learned from. And that right there is the key. What looks like some kind of deep thought is actually a powerful, but really a surprisingly simple mechanism. So let's dig in and see how this thing actually works, starting with a kind of hidden map the AI builds for itself. So the first big clue is this hidden map that the AI creates during training. Researchers call it a token priority graph, or TPG. Honestly, the best way to think of it is like a giant invisible web that connects all the words together, mapping out how important they are to each other in any given context. So how does it build this incredible map? Well, it's pretty straightforward, really. The AI just scans billions, literally billions of sentences. For each one, it looks at the correct next word, and then it draws these little connections back to the words in the sentence that helped predict it. You do that over and over and over again, and you end up with this incredibly detailed priority map.
Now, here's where it gets really cool. On this map, certain words start to form these little posses, these tight-knit groups or cliques, and inside these cliques, all the words are basically connected to each other, which means they all have a pretty similar level of importance when you see them together.
The fancy technical term for these cliques is a strongly connected component, or SCC, and you need to remember this because they are a huge deal. The AI learns to stop seeing just individual words, and instead it starts seeing these high-priority groups of words. These groups become the main target for the very first step of its prediction process. Okay, so the AI has this hidden map. It knows about these special groups of words, but how does it actually use it? Well, it turns out the self-attention part of the AI learns to act like a very simple two-step machine, what the researchers call an automaton, that uses this map to make its final choice. And these are the two steps: hard retrieval and soft composition. I know, they sound a little technical, but trust me, the idea behind them is incredibly simple. First, it finds the right information, and then it just blends it all together. Let's break that down. Hard retrieval, step one, is all about selection. It's decisive. It looks at the sentence it's given, it checks its priority map, and it grabs the entire group of the most important words, that SCC we were just talking about. Everything else, it just gets ignored, completely tossed aside. Then, for step two, soft composition, it takes only the words from that chosen group and carefully blends them, creating this perfect weighted average that forms the basis for its final prediction. Find the group, then blend the group. That's it. Okay. So we get what the machine does. It's a two-step process. But how on earth does it learn to do that in the first place? Where does it get the blueprint for this little machine? Well, the training process is kind of like learning to solve a very specific kind of puzzle millions and millions of times over. And the goal of that puzzle is always the exact same thing: to just learn how to draw a line. That's it. To draw a clean line that perfectly separates the high-priority group of words, the right STC, from all the other lower-priority words in a sentence. For anyone who knows machine learning, this is a classic problem. It's just learning to make a clean, simple separation. And right here, this is the mathematical blueprint it ends up learning. Now, don't worry, don't let the symbols freak you out. We're not going to do any algebra. This is basically just the recipe for that two-step machine. Let's translate what it actually means. In plain English, all this formula is really saying is that the AI's attention mechanism, that's the W, is built from two totally separate parts. There's a hard part for the retrieval, for finding the right group, and a soft part for the composition, for blending the words in that group. It learns two different jobs and then just adds them together to get the final result. So let's zoom out. What does this all really mean? What's the big picture here? What should you really take away from this little deep dive into how AI works under the hood? I think it boils down to three key things. First, next word prediction isn't some fuzzy, mysterious, abstract thought process. It's a clear, mechanical, two-step procedure. Second, this whole thing is guided by that hidden priority map it discovers in the training data. And finally, that super powerful self-attention layer, the thing we hear so much about, basically learns to simplify itself into a really efficient little machine that just finds stuff and then combines it. And all of this leaves us with a really fascinating and kind of mind-bending question to think about. If the very core of an AI's ability to create language is this mechanical, two-step process, what does that say about the nature of its intelligence? What are the real limits of its creativity? It seems the magic really is all in the mechanics.